Okay, so let's see if this thing works, I guess. So if we run on test, it did something. Let's see. Right, so pretty cool. It actually executed the command, right? Well, that's nice, I guess. So it actually worked first try. Okay, so let's continue the Makefile in C from scratch. And today my idea was to be able to actually run the commands that we see in this list, and also be able to check the timestamps of the files that are dependencies, so we know which commands we have to run. And that will kind of simulate how Makefile works. It's not going to be perfect because we don't have the exact same syntax, so we can take a look at how different it is. So a Makefile, it has variables, right? You can expand them like this. You can have these kind of variables which are used to make writing this command easier, because you don't have to write the same name multiple times. And I guess also the other thing is these phony targets, but we don't have those. We only have, so if we check our test file, we only have some extremely simple like a DSL language, right? We have the target, the dependencies, then a semicolon. It was easier for me to do it like this. And in case you also have a command, you have this equal sign and then a command in double quotes. So last time we managed to do the parsing, so let's just run that one again. So we managed to parse everything, and you see that we created this tree structure, and then we printed the dependencies, the command, and the idea is that now we have to check if these files are modified, then we run this command, then we do the same for these two files and we run this command, and so on. So that's the gist of it. So let's go to our main file, and when we do this make plan function, what we have to do, we also have this make dfs. So here we run the command, right? But we have to do some checks first. And here we show file, because it means on this case we figured out that one of the targets is a file, so we have to check the timestamp, right? And if all of the files have like any of the files are newer than the target, then we have to run the command. So that's how we are going to implement this part. So let's see. So first let's see when this command should be executed, for example, right? So in our test file, let's take a look at this one. Let me just zoom in a bit more. And the idea is we need to generate this ds.o file if ds.c or ds.h is newer than the current ds.o file that we have. Or I mean, if the file doesn't exist, it's the same thing. But if this thing is newer, then we have to generate it. And to generate that file, we have to run the command. Like that's the main idea, right? And I mean, I guess if this command wouldn't generate the file, then I mean, it's your fault. But the idea is that this command should generate the target. Right? I mean, it can do whatever, but in most cases, that's what's gonna happen. It's gonna generate this file, and after that, this ds.o file is gonna be newer than these two files. So the next time we try to run this target, the like our make plan function will see that this can be skipped because the file is already newer. So that's what we are gonna do here. Okay, so we have a big for loop over our dependencies. So here we iterate these files, ds.c, ds.h, and so on. So what we have to do is, well, maybe first of all, let's try to figure out the modification date of this target of ds.o, for instance. So we are gonna do that from make, I guess, rule dot target is a string slice, right? And we need to use a function called stat c function. It's called like it has a man page though. Let's see this one. So we have sys stat.h or this kind of stuff, and this stat function, I'm not sure what's the difference between stat, f stat, l stat. I guess f stat works on a file descriptor and l stat, not sure, it has this restricting. I mean, usually I guess I was using f stat most of the time, but yeah, let's try to use stat. Sure, why not, because we already have a string. The only part that maybe sucks is that our string is a string slice, so we have to convert it to a char star, so char pointer path name, but we have a function for that. I think it's string slice to owned. It's the Rust name. I think it was char pointer. Okay, so dsx ds expect, and I think I have like a ds error out of memory. Okay, no, it was fine. So wait, it says expected, huh? It doesn't look good. See, like I have this part and excuse me. No idea why it complains like this. Am I? Okay, whatever. Let's do unreachable. Whatever. I'll figure out why that sucks, but it is what it is. So then we have start, and it returns. It looks like it returns an int, which is like a return code. Let's see what return values it can do. So on success, it returns 0, and on error, it returns -1. And I guess it can do -1 if, for instance, the file doesn't exist. So error no entry, I guess. So if the file doesn't exist, we'll get -1. Let's have int result. Result is equal to this stuff, and then we have path name, and we have a stat buff. So struct stat, and we'll send the reference in here. And here we should get back the file stat. Let's say let's print some information actually. So if result is equal to 0, let's do some printf file okay or whatever, just to see that this thing works. Right, so it works. Now, as I said, for files like ds.o, main.o, or main, it's gonna work because the files already exist, because I generated them. But if the file wouldn't exist, like build for instance, it will return -1, I'm pretty sure. So let's see. So it returns -1 for one of them, which I think it's build. Okay, so then interesting. I was thinking we might need, so inside of this stat structure, it's extremely ugly to be honest, but there should be something like st time of last status change theme, I guess. Time of last modification. That's what we need here. Statbuff dot stmtheme is some kind of time spec. Time spec. Interesting. Oh, so it has seconds. Okay, I guess that's useful. TV sec, which is a time t. What is time t? Well, I mean, we can try to see if it's like an integer. Okay, so it's actually an integer, perfect. Hopefully. Okay, so yeah, we get a time. Right. I guess I'm gonna say target time is equal to 0, and if the file doesn't exist, it's gonna have the target time set to 0 anyway, so that means that it's older than any other file, which is gonna make it run the command. So I think that's fine to keep it like this. Okay, I mean, we don't even need, we can just do that. And yeah, the idea is, okay, we can do some other error checks, like maybe the file, you don't have permissions or something. I wouldn't say we care about that at this point. We just want to get the target time. All right. We just want the target time, and we got it here. And the next thing that we need is, in case we find a file, we need to do some checks here. And we'll have something like int target is target fresh, or I guess new, and it can be, well, it can be a boolean, and I guess by default it's gonna be true, right? We assume that it's gonna be newer, and here we are gonna do dep time, we need to generate a path name, obviously, like here. A path name from the dependency. And dep is the name of the dependency, so it comes here. Right, so if, wait, actually, maybe it's not on the else case. Maybe it's here. Let's think about it. So regardless if it's a file or another rule, we should check this thing. So, but I think it's fine to check it at the end, like it doesn't matter. So we get the path name, then we get a dependency time, right here, dep time, and if dep time is greater than target time, then we should say something like target newer equals false, right? So we loop over all the dependencies. If any of these dependencies is newer, then target newer is gonna be false. And if the target newer is false, then we have to run this thing. So let's add if not target newer, we have to show this thing at least. So again, I don't think we needed this else. I'm just gonna delete it. So it's not gonna show anything except run build because that's the only thing that's newer. Or maybe the example is bad, but okay, let's. Okay, and now you see that main.o is actually gonna be executed again, but the main file it's not, right? And I guess that's because we don't modify the time of that file. So maybe we need another way to propagate that the file is going to be changed, or maybe once we run this thing it's going to be actually changed. Let's use nsec. Maybe nsec is better. Maybe it's going to be a bit more precise, I don't know. Okay, int, whatever. Oh, it's not. Okay. So it's sec and yeah, whatever. So it kind of works. Now the only thing again that I'm thinking about is, okay, this is gonna go in depth first because it's DFS. So it's gonna execute the last command from our Makefile first. So our last one is gonna be basically this one, right? And once it's gonna execute this one, it's gonna come back from the recursive call here. And when it's gonna check the time, the modification date of this rule, which is the parent rule, kind of, it's gonna see that the file is newer, so maybe it's gonna work. We'll see. Okay, anyway, so at this point we have to execute this command. The easiest way I can think of is using system, but I want to use fork and exec vp because that's more interesting than just calling system. But for now, let's just make sure that this is gonna work. So that's the plan. Okay, so here we have rule cmd, and this is gonna be like cmd. Okay, and I mean we can still print it, but it's not. It's stdlib, but I don't know why it wanted include stdlib.h. I mean, isn't it in stdlib? It's not. Yeah, it's in stdlib. Oh, it's ignoring some. Okay. Ds I don't know what system returns though. I guess it returns 0 on success. So let's see. So if I run this thing, it's not gonna execute anything because nothing has changed. But let's change the main C file. Okay, so you can see that it executed this command, and then this one became, this main.o file became newer than main, so it also executed this main file. To be honest, I don't really like it because it relies too much on the modification time. Would be more interesting to try and build an algorithm that figures out, okay, you are going to modify main.o, where is main.o used, or like an algorithm like topological sort. But I mean, you know, if it works, it works. It proves a point. It showcases how Makefile works. I mean, I'm pretty sure this is how Makefile works. So we are trying to be, and let's change the name to exec and see if it, right? So it built itself, which is pretty nice. That's interesting. It knows how to compile itself. Well, this is the easiest self-hosted language I implemented, I guess. It's yeah, compared to Stacklang, but you know, I mean that yeah. And if I run it again, say so, it does that. The only thing, I mean, I'm happy that it does this rule every time because the build file doesn't exist, and that means that it tries to build it, but there's no command that generates a build file or a file called build, right? So whenever we are gonna execute main on the test file, it's gonna come here, it's gonna see that, okay, target newer is probably false, right? Because main file is a dependency, and the dependency is newer than the target. So it's gonna be like, okay, target is not newer, you have to build it. But there's no command that does that, which is what I expected to see from the Makefile as well, but somehow it knows that I mean, we said that build is a phony target, but even before that it knew that it doesn't have to do anything for build, which is interesting. But I guess no, it's doing what we expected it to do. It's decent. Let's do a make clean. And oh, if we do make clean, we no longer have the main file. Let's remove ds.o, main.o, and let's run main test. Nice, so it compiles ds.o, main.o, and then it recompiles main. That's nice. So again, what I said here was I would like to use fork and execvp instead of system. It's in my opinion, it's nice. It's more interesting to use execvp, and so execvp, and the other one was fork. Fork, man. Okay. So why would we need these things? Well, execvp, how it works is, okay, it runs a command, but when it runs this command, it's going to replace the current process with this process. So that's just how the convention is for this function, right? So the idea is this function doesn't return from doesn't have a return. Basically, if it's something like, if it fails, it's going to return an error code, but if the execution works, it's not going to return anything. So yeah. And there are some things here which I remember. Some of these exec functions are meant to be used with things like system binaries. So see, these ones which have path, I think they are meant to be used with system binaries, and the ones with file are meant to be used with things like we have here main, like dot slash or something like that. Or it's the other way around, maybe, I don't know. But yeah, that's the difference between all of these functions. Some of them are meant to be used with system binaries, some of them are meant to be used with like local path. I don't know how to say it. It's like the path from the root versus the path from the current folder or something like that. And then you have the like extra letters, like E, for instance. Here it's used to send some environment variables, I guess. I was looking for one that's maybe gonna let us just spew here some stuff. But yeah, okay. Okay, so let's set up our fork and exec. Okay. So fork, it's also in unistd. Perfect. We don't need to import it that many times. And I guess we can have a function that does that. So static void, it's like in Python subprocess. So we can say something like execute command or something. And it's a good point. I guess it's gonna take in a string slice. because that's what we have. Execute command, and it's gonna get the string slice with the command. Right, so let's do execute command, and we can just say rule cmd here. We don't need this part. I mean, we need something like that, but not instantly. I wanted to see how the... Okay, so Makefile just shows the command, it doesn't show, but I like to see it, so I'm gonna keep it like this. Let's do log info for this part. Okay, and in execute command, what I want to do here is to set up, as I said, a fork. So when we call to fork, this thing is just gonna split the current process into two sub processes, or I guess into the current process and the child process, and it returns PID, right? And the idea is, with this PID value, we can figure out, let me see if they have an example here. Nice, they have an example. So with this PID, we can figure out if we are inside of the child process or inside of the parent or current process. So we run fork, and then we have a few cases here. If we have -1, then we have an error, fork failed. If we have 0, it means that we are in the child process, and if we have a number, we are in the parent process. And why is the convention like this? Why is 0 for the child and why is a number for the parent? Well, it's because the parent needs to know the child's speed so it can kill it. Okay, the video just got demonetized, but it's fine. But that's the idea, right? So the child doesn't need to know its speed, but the parent needs to know the PID, so it can wait for the child process to finish. And maybe that would be a better, a more family friendly way to say it. Okay. So if the PID is equal to 0, then we are inside of the child process. So here we will run the command, right? Else if PID is greater than 0, we are inside of the parent process and we don't really need to do anything. Maybe just wait for the child process. No idea how we are gonna do that, but wait for child process to finish. And on the else case, we have an error. Maybe we can just do this. This panic fork. Not sure if we should just exit, but I'm just gonna do panic. So it's because I don't remember how it worked. I don't think it matters. Okay, whatever. So that's the idea here. So here we will run the command. Let's see. So which one should we use from here? I guess execvp is something that it's really familiar, so that's what I'm gonna use. So execvp needs the following stuff. Needs the command, so we are gonna have to split the string, and needs the arguments. right? And these things are just char pointers, so we'll see how we can do that. Okay, so cmd, right? Let's do something like ds string slice tokenize, and I'm gonna do command, I guess a space, and then let's say we have another string slice for the token. Okay, and this is gonna give us the first thingy. I don't know why I called it argv. I think it's maybe args. Oh, it's argv. Okay, okay. Oh, and interesting idea here. I'm pretty sure argv needs to start with the cmd as well. So this is basically the argv that we send to the command, just like we get the argv here. So similar to this argv, it needs to start with the file name on the first item, and it needs to end with a null pointer. That's how we need to implement argv. Now the only annoying thing about argv, I guess, is that we need to make an array. Yes, dynamic array. Let's call it args. Let's call it args, and let's initialize it. Yes, dynamic array init, and the items that we are gonna have in here are gonna be char pointer, right? Okay, so first things first, dynamic well, have another idea. Let's do something like this, and I'm pretty sure this function returns 0 if a token was found, and 1 if the string slice is empty. So we can do something like while this thing is 0, right? We tokenize the string, and we can do something here like if cmd is equal to null. That's when we are gonna know that is the first item. Char pointer buffer. We need to do this thing every time anyway, so let's just do something like this into buffer, and if cmd is null, we are just gonna copy it here, right? And then the other thing is dynamic array append. We can do the unreachable error handling. We append into our args, we append a buffer, right? And then at the end we need to append a null. But you know, we cannot do something like this. We need to because dynamic array append uses memcopy. If I'm pretty sure it does memcopy here. Yeah, so we need like a reference to a 0, so we can copy a null there. But at the same time, it's probably gonna be null anyways, so it's fine. Okay, and then argv, it's a char pointer. Is gonna be equal to args.items. Right, so inside of these items, we are storing char pointers. So items is gonna be like char pointer. Hopefully, I think, I'm not sure. We'll see if it works. But this should be the array that we generated here. Not sure if we need an extra null. I mean, we can just manually put it there. So for instance, we can do something like argv of args dot count is equal to null. So we can manually put it there. We don't have to worry about it. And then we just run the command, and if this thing fails, it fails. But as I said before, it replaces the current process when it works. So yeah, we can say if this thing is not equal to 0, then we can panic. execvp. And here we need to wait for the child process to finish. Fork wait for child. How can we with a wait? Okay, so we have a status, I guess. In status, then child pid, whatever. Oh, it's called wait pid. Wait. Okay, like this. So wait pid. We're gonna call here wait, because we already have the pid. We can just say wait pid. We send in the pid of the child, then status, and I guess 0. And this function comes from wait. Okay, and I see it returns something. Wait for a child matching PID to die. So funny. But I don't know what it returns. Oh, -1 for errors. Okay, so if this thing is less than 0, I guess it is -1. We can say something like yes, panic. But yeah, that's the idea. We have to wait for that PID. That's why the convention is like this. The child will have 0 and the parent will have a PID when you call to fork. Okay. So let's see if this thing works, I guess. So if we run on test, it did something. Let's see. Right, so pretty cool. It actually executed the command, right? Well, that's nice, I guess. So it actually worked first try. That's a new one. I mean, I kind of knew how to do these things, so yeah, but I wasn't expecting that the C code will be that easy here with these because yeah, we use string slice, and also when we parse when we parse this thing, we parse it as a single chunk. So here we have to split it by space, which kind of sucks, but if it works, it works, you know what I mean? And yeah, actually, see, argv needs this cmd to be added as well in the beginning. It's a thing that I just remembered when seeing the name of this argument, of this function, of this parameter. But yeah, let's see if we don't put a null at the end, what happens. I guess it's already a null there, so yeah. Anyway, but yeah, hopefully it was interesting to see how you run this with fork and execvp instead of system, which is usually preferred, I would say, because it's safer. Someone could say that, although you can run rm-rf, yeah, whatever, you can still do weird stuff even with execvp. So, but yeah, I mean, I'm surprised it worked first try even on NixOS. But yeah, okay, so then yeah, like a short recap, what we wanted to do was to run some commands based on the timestamps. So we wanted to make sure that we run only the needed commands and we don't just for doing the incremental build, right? That was the idea here. So we had this main.o file, which maybe here it changed because we modify main.c. So our build tool was like, okay, let's rebuild main.o because main.c is newer than main.o, and then main.o became newer than main, so it executed the other command. So that's what we wanted to simulate, the same thing that make does. Now the only difference with make is this thing is much simpler, and as I said last time, maybe it's an interesting idea to have manual entry points. So here, for instance, what if you can say build? So you run the build thing. Maybe it's gonna be like dash target, and you can specify, okay, run the build, run clean or whatever. Like what if here we had clean, which removes main, right? Something like that. And as I said last time, maybe that's like it would be a good idea if you want to learn. Maybe it's a good idea to just take this code base and try to add that extra flag, because you'll learn how to parse the command line arguments. Even if it's with my library, you still get that done. And then was other thing, I guess when you do make plan, you you have to change here which rule you start with. So that's the idea. And I think that it's a good way to take a code base and then add some small change to it to learn stuff. So if you made it this far into this session, then I guess maybe you want to do that. But yeah, like the short recap, how we managed to achieve that was just looking at the modification date for the target, and then we look at the modification date for each of the dependencies, and if any of the dependencies is newer, then we have to rebuild the entire target, right? And yeah, then we just execute the command. And initially we did it with system, but then I said, okay, let's see how we can do it with fork and execvp, which is more like, I don't know, the right way to do it, I guess. I don't know. But yeah, hopefully this was interesting for you. And yeah, let's see if anyone wants to implement that flag. I'm curious if anyone will actually do it. Like if you actually do it, leave a comment, maybe make a PR. I'm not sure. Like I'll have a link to the repo in the description. Like always check the description if you want to see which repos I was using or stuff like that. I usually link them. So yeah. And let's see in the next one. So see you.